temperatures rarely get below freezing. So it might get down to 37 or 39 or 41. In the summertime, it might get up to 80. Every once in a while, it does make it into the 90s. And I think the all-time record high might be 100-ish Fahrenheit. But in general, you have a much smaller range of temperatures. You'll get down to the upper 30s in the wintertime, and you'll stay in the upper 80s in the summertime, or even upper 70s. So the water, the fact that the United Kingdom is an island, and there's a flow of relatively warm water, okay, warm, air quotes, moving toward England and Ireland and all of those places, means that they are actually experiencing a moderation of their temperatures. They don't get as cold in the winter, they don't get as warm in the summer. When you get an area that's inland, they have huge variations. And so that's why the weather is so extremely cold in places like North Dakota, South Dakota, Minnesota, I mean, you name it. Even Texas, even especially like the Texas Panhandle. Amarillo will be 100 degrees, and then the next week it's freezing. So that leads me into the blob. So what we're talking about right now is an anomaly. An anomaly just means something that's out of the ordinary. That's been observed for the last couple of decades in the North Atlantic Ocean. So this is up by Greenland, basically. And the easy way to look at it, or the easy guess as to why it's there, is that it is a melting glacier. That you have the glaciers over northern Canada and you have the glaciers over Greenland that are melting, and therefore the cold water drains into the ocean and you have this pool of colder water. And that is true, but it is much more complicated than that. As I'll explain here in just a minute, there is a large circulation, and this is a mouthful. It's known as the AMOC, okay? And it stands for Atlantic Meridional Overturning Circulation. What it basically means is that this is not just a flow of water. You think of a flow of water on the surface of the ocean, but the Atlantic Ocean is very deep, as all oceans are. And there are circulations that drop from the surface down below the water and actually flow all the way down to the seafloor. And these circulations are very long and very complicated. But the bottom line is they've been kind of set up for a while, at least as far as we can tell. These circulations have been established pretty well for a long time, and that's what helps sort of govern or at least influence the type of weather that we see around the world, or at least around the Atlantic Ocean. And if that whole thing gets disrupted somehow, well, you would have far-reaching consequences. So I'm going to use a couple of models of the Earth here and talk to you about exactly what my understanding is of what's happening, what could happen in the future, and what effects it might have on you, depending on where you're watching. If you're watching us from the Houston area, from Texas, or from Kansas City, New Orleans, New York City, or Timbuktu. I probably won't talk about Timbuktu, but the rest of the areas we're going to talk about it. So let's head over to here. I'm going to switch cameras around and let's talk about it. So here we are. I'm at my weather computers. Let's talk about the cold blob and just the overall circulation of the Atlantic Ocean and how that could be affected by this anomaly, the cold blob in the Atlantic. So here's a look. So the way things work in the Atlantic Ocean, and it actually works very similarly in the Pacific Ocean, is that for the southern parts of the North Atlantic Ocean, meaning near the equator, kind of what you would call the tropics, we have the trade winds that flow. And they kind of blow like this. They come in from the east or from the northeast, and this has been known for hundreds of years, maybe longer than that probably, where the winds kind of in this part of the world blow toward the equator. And then over here, as you get farther off toward the north, we have what are called the westerlies. So let's say the westerly, I should change that color here. Let me make that blue to show that it's a little bit cooler. So here we are. So here's the westerlies, which blow in the northern part of the Atlantic Ocean. Let's just say they go like this. All right. And of course, look, they always change. It's not going to be always this direction, but this is the overall general flow. So that's the way this is established. And by the way, there's an area in between here, which is known as the doldrums. That's like back in the days where sailors and shipping and all of that stuff, they would get kind of stuck there because the winds were very light. And then down here is the equator. So flows something like that. I probably didn't draw it perfectly, but that's approximately what we're looking at here. So I want to simplify this and just show you the sort of the what you would call the conceptual model of what we're talking about. So let's just say that up here in the North Atlantic, instead of drawing those idealized kind of arrows, let's just go like this. So that's the mean wind direction is going from west to east. And then the mean wind direction down here in the equator, bear with me here too, don't click off yet. It's going like this. So it's going to be blowing from east to west. Whoops, sorry about that. It's going to be going like this. So what happens is this. So in between, you end up with an area of high pressure. So you end up with this. An H right here over the middle of the Atlantic Ocean. And wrapping around that, you end up with water that wants to flow down off of the high. Just like gravity wants to pull something down off of a hill. There's a high that forms in the middle, and so the pressure wants to push even the water outwards. And because of the Coriolis force that we have, because of the rotation of the Earth, it ends up turning like this. So you end up with this flow of water around the Atlantic Ocean that goes like this. And this has a very interesting name. It is known as the North Atlantic Gyre, G-Y-R-E. Now, I did have a professor. I took a graduate course in the general circulation, global circulation at North Dakota State many, many years ago. And my professor called it a gyre. So I don't know, is it the North Atlantic gyre or gyre? You know, tomato, tomato. That's sort of the situation. So you have this high in the middle, and what you end up with is a flow like this. So you have warm water from the tropics that flows into the Caribbean Sea. You have warm water from the tropics that flows up the eastern seaboard. So similar to what I mentioned about how London is not as cold as Minneapolis or something like that. If you were to look at a map here, let me just clear this real quick, and let's just look at a place like Boston. So if you were to look at Boston and then compare it to also, let's say Rapid City, South Dakota, okay? They're approximately the same latitude. Boston does get snow, and they do get cold. But when you take a look at the extremes of temperatures, Boston, it might get into the middle and upper 80s in the summertime. I'm sure it hits 90 every once in a while, but not often. Rapid City will hit 90 often. Wintertime, Boston might get down to 0. Rapid City might get down to minus 30. So the east coast of the United States is, in fact, you can even look at it, farther south might be actually a better example here. When you take a look at the difference between, let's say, maybe like Norfolk, Virginia, or an even better example is like the Outer Banks of North Carolina. And then you go over to the same area over here and you compare it to Oklahoma City. Well, I think you probably know that the Outer Banks of North Carolina are going to have a much different climate than Oklahoma City is. Oklahoma City is going to have very hot summers, cold, windy winters. The Outer Banks are going to be windy. They'll have kind of hot summers, but winters that are not as cold. Very rarely do they get snow. Much more rare that they'll freeze, compared to Oklahoma City. So anyway, I'm pointing that out just to show you how the influence of the ocean circulations can really change things. And so, for example, over here, this is called the Gulf Stream current. The Gulf Stream current. And the Gulf Stream carries, and I want you to stay with me here and realize how important this is. It doesn't just carry warm water.